Design patterns are general reusable solutions to commonly occurring problems in software design. Understanding what they are and when to use them will greatly improve your development skills and the quality of your Flutter applications. In this video, we will look at the decorator pattern, what it is, and how to implement it. So if you want to improve your Flutter dev skills, hit the subscribe button and ring the bell to get notified of similar videos that will vastly improve your skills. So what is the decorator pattern? The decorator pattern is a structural design pattern that allows the addition of new functionality to an existing object without altering its structure. Simply put, it allows us to decorate existing classes with new behavior without changing the classes themselves. Some of the common use cases of the decorator pattern through which we will implement in this video are the database or the network retry policy and also logging. Decorators are small classes with a single responsibility and can be composed together to form a larger structure. And as a result, we can have a chain of decorators accomplishing different tasks, where we can have a decorator for our network retry policy, and on top of that, a logging decorator. So let us now jump into Visual Studio Code to see how the decorator pattern is implemented. So here we are in Visual Studio Code, and I have set up a simple project to demonstrate the decorator pattern. So I have created a simple screen with a button and a message to display whenever some data is returned from this service. I have also created a service to simulate some network call and return some information. I'm also using the data connection checker package here to check if there is some connection to the network and return a socket exception with no connection. So the scenario that we are dealing with is that we have created a service and we are almost at the completion of the project. Say, for example, we're working on some enterprise project or even a personal project, but we are far ahead in the development. Already created our service to handle network calls and to fetch information from some back end. Now, some additional requirements is given that whenever there is no internet connectivity, that the application should not just fail, but there's a retry policy to be implemented. The application should retry, say, for a set amount of time, checking for network connectivity. And if that time is passed, then we return a message. And so this is where we instead of trying to change or modify our app service, we could use a decorator. And this is where the decorators shine. So I'll create a folder and I'll call it Decorators. And inside that folder, I'm gonna create my app service retry decorator. So app service retry decorator. And for my app service retry decorator, since it will be decorating my app service, it must implement the same interface that my app service implements, which is iService. So inside my app service class, there's this abstract iService. So I'll implement that interface. And now inside my decorator, I'll pass in the object that I want to decorate, or the decoratee. So in this case, it will be my app service. So I would say iService and I'll call it decoratee. And I'll inject that into the constructor. So app service decorator, decoratee. So inside the get data now, here is where I would implement the retry policy. So for my retry policy, I want that the maximum wait time should be 7 seconds, but I want that every 2 seconds, that it must wait every 2 seconds before it retry the network call. And if there is no connection, then it add 2 more seconds. So it wait 4 seconds and retry. And then it wait 2 more seconds. So that would be 6 seconds and then retry. So how I would implement this is that you would normally have the retry policy. So I would say, and this would normally comes from some config file, but for now I'm just using it as a part of the decorator itself. So I'm gonna say maximum duration, and I'm gonna say I want it to be 7 seconds. So that's the maximum duration. And now inside of the get data method, I'm gonna say retry in seconds equal, I'm gonna initialize this seconds to 0. And then I'm going to say while the retry in seconds is less than the maximum duration, then this is where now I'm going to try, and I'm gonna wait. I'm gonna try and make the network call, but first I'm gonna wait the amount of seconds. So I'm gonna say future delayed, and I'm gonna say retry in seconds. Then after I wait, then I'm gonna say, then I'm gonna make the network call. So I'm gonna say decoratee get data. So if there is a socket error, mean there is no connection, there's a socket exception, then I'm going to say retry in seconds, and I'm going to increment it by 2 seconds. I'm going to increment the wait time by 2 seconds. And then if my retry in seconds is now greater than the maximum duration, that's when I'm going to return the connectivity error. So in this case, I'm gonna create a variable called data. So I'm gonna say var data whole string, and I'm going to say data equal e to string. Socket exception catch. So now here I'm gonna say data equal get data, and I'm going to return the data if it is successful without waiting on the retry policy. I'm just going to exit the while loop. So this is our decorator. So we're going to decorate our app service and manage when the network call or the method that fetch the data from the network, when it is called. So we apply some level of retry policy to decide when we hit the network for the information. If you are familiar with .NET middlewares or even middlewares from Node.js and other technologies, it's a similar thing where the middleware is executed before the actual call that you are making, and the middleware either modify some input before the call is made or make some kind of decision as to how the call is made. So the decorator pattern basically behaves like a middleware. So now inside of our main, I'm going to say here, instead of passing in the app service to our homepage widget, I'm going to pass the decorator. So I'm going to say retry decorator app service retry decorator, and then the decorator is the app service itself. And then I'll inject that into my home page. So if I should run this, then because I'm connected to the internet, I'm expecting everything to work as it should. So I'm fetching the data immediately. But if I should disconnect from the internet, if I should turn off my Wi-Fi, you would see that it is running until it reached the maximum threshold. Then it would return the exception. But if the user connects to the internet before it reaches the retry maximum, then it would automatically fetch the data, right? So I reconnect to the internet while it was trying to fetch, and it automatically retry the network call and fetches the data. So you can use decorators as an automatic retry when there is no network connectivity, instead of using some third-party library. Because the truth is, the less amount of third-party libraries you have in your application, the more stable your application is, especially if you create your application in such a way that it is tightly coupled with third-party libraries. So the decorator pattern and other patterns, as you understand them, it will help in accomplish some simple task that you would normally try and find a third-party library for. So that is our app service decorator. But as I've said before, that we can have a chain of decorators upon decorators. And so I'm going to create the logging decorator. Logging as in to log information. I'm going to create that decorator and show you how it is used to wrap decorators, and also so that all the decorators are run in the same network call. So I'm going to create another decorator. I'm going to call it app service logging decorator. So now here is our app service logging decorator. And so it basically just log the time the service call took. So it's the same principle. It implements the iService interface. It accepts a decorator of the same type and then decorate it before calling the method. So now back inside of our main, I'm gonna create that logging decorator. It's the app service logging decorator. And now I'm gonna pass to it the retry decorator. So the logging decorator will be executed first, then the retry decorator, then the app service itself. And if I should run this and look inside my console, then you should see it logging the message. So service call took X amount of milliseconds. Now normally in a production application, then you would have some logging framework or logging to the database, whatever information that you want to log about the app service call. Now the manner in which we compose the decorators determine how they are executed. So if I had composed it in such a way where the logging decorator is injected into the retry decorator, then what would happen is that every time there's a retry, it would log that information, But I did not want to log the information every time there's a retry. I only wanted to log the information to see how long the network call takes. So that is the decorator pattern, guys. And if you have learned something, please like and subscribe and share this video so that together we can build our skills, we can improve our skills as Flutter developers. I will continue to share more videos about design patterns to improve our Flutter development skills. So see you in the next one, guys.